All right, 1.7, we're going to transform some functions. So in our last class, 1.6, we did all our parent functions, right? So we know that y equals x squared is a parabola, and it touches 0, 0 down here. So today we're going to learn what happens, and we looked at this with our classwork a little bit, just on the graphing calculator, but now we're going to know algebraically, by looking at the equation, how to shift those around. All right, so we can see here, if we have a plus c or a minus c outside of the x. So in this equation, if I had y equals x squared plus 2, this is away from the x. So this is going to be a vertical shift. So if I were to graph this, instead of 0, 0, I would have 0, 2 as the vertex of my parabola. It'd be shifted up by 2. If it's inside with the x, all right, so if I had this, y equals x minus 2 squared, then it's a horizontal shift, and it's going to be the opposite. If it's a minus, we go to the right, which you normally think is a plus. If it's a plus, we're going to go to the left, which is the opposite. So if it's horizontal, we're going to do opposite shifts. Okay, so on this one, minus 2 means take me to the right by 2. 1, 2, and our parabola would start from 2, 0. All right? So that's pretty much what we're looking at today, horizontal and vertical shifts. We'll talk about stretching as well in a couple of examples. But first things first, let's see if we can graph these. So A, x cubed minus 1. So I know that x cubed looks like this. It goes through 0, 0, 1, 1, negative 1, 1. Those 3 points are important, and it's going to curve off of those. All right, so to do problem A, I know that I am a minus 1. That minus 1 is not in with the x. Okay, it's away from the x, so that's a vertical shift. So I'm going to shift this down by 1. All right, so this dot goes down, down, and down. So my new graph would look like that. Let me just do it right on there. I can redraw it over here. So here, here, and here would be my new 3 points for shifted down by 1. Okay? For B, we're going to shift up by 1, but we're also going to shift left 2. So this part in here, it's in with the x, so that's going to be a horizontal, and horizontal we go opposite. All right, so we're going to shift up 1 and left 2. So originally, we put our 3 original dots in here. Okay, all 3 of those dots are going to go up 1 and left 2. So up 1 and left 2, up 1 and left 2, up 1 and left 2. It's going to look like this. All right, so we've transformed that graph by shifting it left and shifting it up. See if you can figure out what to do with exercise 7. All right, so the next thing we're going to look at is reflections. So this is flipping it, mirroring it. We've talked a lot about this with symmetry so far, all right, and the rules still apply. So if we look in here, if it's a negative out front, we're going to have reflection in the x-axis. We're going to flip it up and down. So same rules. This is a vertical flip. And if the negative is in with the x, then it's a horizontal flip. So same rules as we just did for the shifting, all right, as to where to look. So let's take a look here. All right, so the graph of the function given by y equals x to the 4th. Remember, f of x is the same as saying y equals. So f of x equals x to the 4th, y equals x to the 4th is this graph right here. All right, so it has it looks like a parabola. It's just a little flatter there on the bottom. It flattens out. All right, so let's take a look at some transformations. All right, so we want to find an equation for each of these functions. All right, so let's start with g of x. All right, so first things first, I'm going to look at this. We are shifted up by 2. Right, 1, 2. We got shifted up. So we know that this is x to the 4th plus 2. We're shifted up by 2. And then we're flipped vertically. We're flipped upside down. All right? So we want this negative to affect everything, not just the x. All right? So we're going to put the negative on the outside away from the x, right? And that's going to tell us that this is flipped vertically. All right? So same thing on this one. This is going to be flipped vertically as well. We'll have a negative on the outside, and this will be x to the 4th. Okay, but then let me actually erase that because our shift is happening with the x. It's a horizontal shift. It's shifted over to here. That's 3, 1, 2, and 3. And so we're going to go opposite, minus 3 to the 4th. Okay? The negative's hanging out on the outside. I guess really I don't need these out of parentheses. Negative x minus 3 to the 4th. All right, see if that makes sense, and try exercise 15. Okay, so let's take a look at these. Compare the graph of each function with the graph of the parent function, square root of x. So just let me throw that up there real quick. The parent function of the square root looks like that, and a couple important points: 0, 0. The square root of 1 is 1, so that's on there. And then the square root of 4 is 2, so that's also on there. 4 comma 2 is also on the square root graph. All right, so let's take a look at how these are all going to look. If we have the negative here, this is outside, so this is a vertical flip. So for A, we're going to flip like that. It's going to be upside down. For B, this is inside with the x, so that's a horizontal flip. So we're going to take this original graph and flip it horizontally. And then C, we've got a couple things going on. We're going to always do our translations first and then our reflections. So on this one, first we're going to look at the shift, left 2. Okay. Normally, I would look like that, but I'm flipped horizontal or vertically. Sorry, so we're going to be like that. Starting over here at negative 2, 0, and then flipped vertically, so I'm going down. Use that information. See if you can try exercise 25. All right, so far we've done rigid transformations. Okay, a rigid transformation is when the original parent function isn't changed, it's just moved. Right? So we flip things over, but we haven't done any stretching. So a non-rigid transformation is if we stretch the original graph. All right? And so that's what's going to happen. What this whole paragraph is saying here is if we have coefficients in front. Okay? And the way I remember this is that fractions, starting with an F, are fat. Okay? So that means that the 1/3 is going to be fatter than the 3. And again, these are absolute value functions. So the 3 here is going to be stretched by 3. So my normal absolute value function looks like this. 1 matches up with 1, 2 with 2. Right? So in here we're going to stretch it by 3. So this one would match up with 3, 2, comma 6, as opposed to 1, 1, and 2, 2. Over here we would shrink it, so we would have to go all the way out to 3 before we got to 1, because it's only 1/3 as tall. So fractions are fatter. We're going to either stretch vertically or squish vertically on these. So see if you can either stretch or squish exercise 29. All right, and I believe this is our last one. Yes, it is. So let's compare these graphs with the graph of 2 minus x cubed on this one. So if we were to double this thing, it says function of 2x, right? So what that means is we've got 2 minus, instead of x, we've got 2x cubed. I'm just taking 2x and plugging it in when I see x up here for the original function. Okay, so 2 minus 2x cubed turns into 2 minus 8x cubed. So from the original, the only thing that changed is that I've got 8 here when I only had a 1 right here. So that means we are stretched vertically by 8. Same idea on this one. If we say 2 minus a half x cubed, so the only thing that's going to change is this is going to be 1/8 x cubed. All right. So we are stretched wider. We're getting fatter, right? Fractions are fatter. So in this case, we're stretched horizontally by 8. We're 8 times as wide, or we're 8 times shorter, squished down. All right, so use that information on exercise 35, and that'll do it. So any questions, make a note of them, and please make sure we look over them in class. Good luck.